Everyone knows solid programming. Single responsibility, open close, gets a little hard there. Why don't we know the rest of it? How come we only know the first part of it? Probably because it depends so much on dependency injection. So what is dependency injection? What's a dependency? Maybe it starts with these people. When they have a kid, that's called a dependent. Then eventually, he grows up, gets a Nintendo. It's cool, he buys some games, everything's going good. And then he buys a special game, and now he needs 4 players. Now he has to go back to his parents and ask for a 4-player adapter. So he has to go back up the chain, get something new, and then plug it back in just so his game can get used. It's simple when you only have one dependency, but when you move up that tree, all of a sudden you have to make a whole bunch of changes in your code to get everything working. Let's take a look at how that code looks before and after getting that 4-player adapter. What changes need to be made, and how do we handle that? At first, we have a pretty deep dependency tree. We have the parents, we have Rob, we have the Nintendo, and the Nintendo has games that it plays. The games don't really have many dependencies, they just depend on the Nintendo. Until the 4-player adapter comes in, then we need to make a change to that object. Then we need to make a change to the object that's passing it in, and the object above that. It's cool in a small app, but what do you do in an enterprise app when all of a sudden you have a chain of 16 dependencies? What if we could remove this dependency? What if we could just get it out of there? And the only thing that needed to reference it was the Nintendo. The Nintendo is the only thing that needs to know about it. The parents surely don't care. The great news is in most frameworks you can. .NET Core even has it built in. All we have to do is go over, register our dependency, and we can get rid of it everywhere else. As soon as we pass it into our constructor, it'll go pick it up and use what it needs. So now all we have to do when a class needs a dependency is add it to the class that needs it, like it should be. So we've solved that D up there for solid, but this next letter is I, and that requires interfaces. So why would we move it to interfaces? Well, interfaces really make dependency injection better because now you can sub out interfaces for testing interfaces. You don't have to deal with that live implementation. If something's talking to a database, you can just pull data back from a file. You don't need to do anything. You don't need to use all the real implementations. It also makes it flexible. If you need to change, all you have to do is implement the interface. Your code will work just fine like that. This gets us to the L, list off substitution. And just like that, where it's solid, all you really take is the single responsibility, open close principle, and dependency injection, and you're done. If you like this video, subscribe and check out some of my other videos.